Suppose you walk 20 meters in one direction. I want to stop right here and draw a picture describing what we've just learned from this problem. This is generally the best way to solve physics problems because you write down the information as you read it and extract it. So let's say we start right here at this position, and then we walk 20 meters in one direction. That's what this path represents, and we can give it a label of 20 meters to represent the distance. Then you turn around and walk 5 meters. We can also draw this on our picture and add to it, showing that we went the other direction and walked an additional 5 meters. What is the total distance you've traveled? Distance is usually represented with the letter D, so we can write this down and then add up the total distance that we travel in this problem. So we first go 20 meters, and then we turn around and go another 5 meters. So the total distance traveled is 25 meters. Then it says, what is your total displacement from the starting point? Since displacement is a vector, we need to have a starting point, and so that's where we began. Displacement is written as delta x, which is math speak for a change in x. That is, some final position minus an initial position, because x represents position. On the graph, this is represented by a vector pointing from the initial position to the final position. xf is the final position from our starting point, and we know that it's 15 because 20 minus 5 is 15. xi, or the initial position, is equal to 0 because that's where we started. 15 minus 0 is just 15 itself, and so the total displacement is 15 meters. I want to draw another picture to drive this fact home that there is a significant difference between the total distance traveled and displacement. So my blue line represents the total distance traveled because I went 20 meters and then I went back another 5. But the displacement in red only depends on the initial and final positions. A racquetball is thrown straight upward near the edge of a 36-meter building on campus. So I have a building and it is 36 meters tall. It rises 10 meters and then falls to the ground. It goes up and then comes all the way down to the ground after it's thrown upwards. We can call the ground 0 meters. Then the problem says find the displacement of the ball. So last time we found the total distance traveled and the displacement, but it's not asking for the total distance. It's asking for delta x, the displacement. This path represents the total distance traveled, and this is the displacement, just a straight line that only depends on the initial and final points. But without even doing the calculation, we can say that the displacement is 36 meters because that's the height of the building. Since it started at the top of the building and ended at the ground, the displacement is 36 meters. But we also need a direction, so it's down. The total distance is a scalar, or just a number, while displacement is a vector. It has both magnitude and direction, rather than total distance, which just has magnitude. That's what it means to be a vector, magnitude and direction. Your friend Sarah is doing her warm-up and runs around a circular track, which has a radius of 60 meters. I want to draw this right now since we've extracted this from the problem. We have a circle, and the radius is the point from the center to the edge of the circle, and that distance is 60 meters. She's taken a math class and asks you what the total distance she ran was, as well as her displacement. What do you tell her? Let's say she starts here, though it doesn't really matter because it's a circle, and then she runs all the way around once. Well, this path in blue that I've drawn is d, the total distance traveled. The total distance she ran is just the circumference of the circle, because she ran all the way around a circular track. We know that the circumference of a circle is 2 pi r, where r is the radius of the circle. Since we're given this information, we can plug it in and multiply 2 times 60 to get 120 pi for the circumference of the circle, which is also the total distance traveled by Sarah. What about her displacement? Remember that delta x is a displacement, and it only depends on 2 points. the final position and the initial position. Since these two values are the same, her displacement is 0. The displacement is always 0 when the final position equals the initial position.